market for CO2 glue this summer. So first, what is CO2 glue? So it's a tunable polyhydroxyurethane compound. And a polyurethane is a polymer composed of organic units, and they're joined by carbonate leads with nitrogens, carbons, and oxygens. So I'll show you that here. So specifically, our CO2 glue is formed by mixing a thiol, a carbonate, and an amine. We have to add heat or UV to get curing, and we end up with our final polymer shown here at the end. Up here in red, you can see the carbonate link, and then the addition that our polyurethane has is that we also include sulfur, which can help us with binding to metals. And so polyurethanes are a $20 billion market a year, and there are several applications for polyurethanes, including uses as adhesives, sealants, surface coatings such as for warehouse flooring, binders often used to coat playground flooring, resins for making molds, hydrogels which help people who are moist and aid in healing, and also conformal coatings of medical devices. So we had many different ranges to take this CO2 glue into and then figure out which is going to be the best marketplace for us. And so learning about what our CO2 glue is compared to competitors, like other products on the market, it consists of two liquids that we have to put together, and then we add heat or light to get the curing. But compared to our competition, almost all of them will take toxic isocyanate chemicals, combine those with an alcohol, and get their final polyurethane. And these isocyanates, when you're exposed to them in lower doses, will cause skin, eye, nose, and throat irritation. And as you're exposed to them more, you can actually develop wheezing and a persistent cough, and even go all the way up to asthma and persistent skin rashes from this exposure. So it's really important that we want to remove these isocyanates from any polyurethane compounds. And that's exactly what our CO2 glue does. There's no isocyanate chemistry at all in our CO2 glue. And so it makes it much safer for the user. An important note is that when you're using polyurethanes, the isocyanates are only toxic while you're actually mixing them, and then after the curing process, they're no longer toxic. And so this is more important for the people who are using the glues and actually applying them, rather than the end users who will get a final finished polyurethane product. And then our CO2 glue is known to have excellent adhesive properties. There's actually more hydroxyl groups on our polyurethane, helping it bond to polar compounds such as metals, and then also that added sulfur, more polar compounds such as glass, and the added sulfur helps us bond better to metals than existing polyurethanes. And then the inventor say it's also easily tunable, so we should be able to add like silica gel to change the flow properties and get several different variations on this product. And we also believe it will cost less for people applying it because they no longer need things such as respirators when applying large amounts of polyurethanes, saving money there. And we also believe it should cost less to make this product because we're reusing some recycled products such as sulfur and carbon dioxide. And so we believe that this would lead to us to describe this product as more environmentally friendly.
So in investigating the environmental angle for CO2 glue, we found that there's two selling points. The first is that we are currently using repurposed sulfur, and we are also using recycled carbon dioxide. Now, due to the increase in the number of companies who are using an eco-friendly, or taking an eco-friendly marketing strategy, the FTC, Federal Trade Commission, has produced green guides describing how a company can go about marketing itself as environmentally friendly. And according to those guides, it's not in a company, companies are not allowed to just call their product green simply because they're using recycled material. We need to show how, scientifically, how this product is better for the environment. So what that means for CO2 glue is the carbon dioxide sequestration process needs to prove that it's taking in more carbon dioxide. More carbon dioxide is being used to produce the product than is being created in the production of the product. So with that said, our recommendation is not to market the product so much as a more environmentally friendly adhesive, but compare to the competition a healthier and cleaner product.
So currently there are 2 pending patent applications filed with USPTO, and after clearing some technical hurdles, we're now about 2 months away from enjoying monopoly in this technology for the next 17 years. And if the first patent was filed in 2011, so it ate up 3 years there. Alright, so so now that they have this soon-to-be patented technology, what should Nettle do with it? In pursuit of our market feasibility studies, we went out and we conducted exhaustive interviews with over 35 people from 10 different industries. And as you can see here, we talked to Nike with their footwear department, conformal coating, surface coating, orthodontists with the use of glue in their bracings. And at the end of the day, two companies really stood out and they showed great interest in our new technology. Go Green Products, which Eric will tell you a little bit more about in a little bit, and Bob Smith Industry, which I'll go over that now. So epoxy glue is a two-component mix and works very much like super glue. It's based on very simple chemistry, and as we have our technology today, it's readily tunable into this product. And so as you see here, the bottom epoxy is Bob Smith Industries 5-minute working time epoxy. This will be a great market segment to enter right now and begin our commercialization process because, as Tasha mentioned earlier, isocyanate is only toxic when it's being applied, and it is the users and the consumer end that are most vulnerable to this toxicity because often they're without any adequate protection. It's so toxic, in fact, that it has made to EPA's concern list, and there's talk about possible complete ban of this product in the future, of isocyanate chemical in the future. Bob Smith Industry will make a great strategic partner because they've been around for 30 years, growing steadily over 30 years, and they have reached roughly about $12.5 million in revenue. They have established over 1,800 dealerships worldwide, 80% of their revenue coming from the hobby industry, but they also have activities with other industries, including dental labs and aquariums. And most importantly, they do in-house product development, including the testing phase. And so with the right partnership between Netto and Bob Smith Industry, we can work together and fine-tune our formula and go straight to market using their existing channel of distribution. And now Ryan will talk about formal industry.
So two of the markets that we looked at, the recommendation of the inventors, were the general conformal coating market and then more specifically the conformal coating of medical devices. Conformal coating is the process of applying adhesives to electronic circuitry to protect the circuitry from extreme environments of debris and humidity. It's a high-value market that's rapidly growing, and it's usually the very last stage in the manufacturing process of electronic circuitry. When we researched the industry, we contacted 3 groups of companies. The first group of companies were companies that produced and sold the adhesives used for conformal coating. The second group of companies were companies that received orders for circuitry manufacturing and then actually applied the coating. The third group of companies were companies that would design circuitry, select the materials, and then outsource the production to the second group of companies. Among these 3 groups, the group that showed the most amount of interest is the second group, the ones that actually applied the coating. The primary motivation for their interest was the fact that our glue was less toxic, so they would be able to eliminate many of the safety precautions through the manufacturing process, such as respirators and high-rate exhaust fans, which would allow them to run a low-cost facility and provide them with direct cost savings. Unfortunately, the group of companies that makes the decision of which adhesives to adopt is the third group of companies, and they were not very enthusiastic about our product based solely on indirect cost savings. So then we looked at the conformal coating industry for medical devices. We thought that this would be a very opportunistic market for our glue because of the high value that the medical field places on low toxicity. Unfortunately, we found that there is already a suitable substitute product called Parylene. It's lightweight, biocompatible, non-toxic, and it's extremely effective. Despite being expensive, inherently inefficient to apply, and unsuitable for high-volume manufacturing, we found that the industry is very risk-averse and very unlikely to adopt a new adhesive.
So after Ryan's initial limited success with conformal coatings, the $1 billion custom coatings industry looked like a solid fit for CO2 glue. However, in these mature industries, there's been regulation in place for the last 3 decades about isocyanate exposure, and that's given these industries a lot of time to invest in engineering solutions, such things as spray booths, personal protective equipment, and robotics, part of their fixed costs. So then looking instead at one-time large applications, periodic or one-time large applications of polyurethane coatings in industries like commercial or industrial floorings, shipbuilding, or pipe laying would be better suited industries for the CO2 glue. Any of these industries that CO2 toothpaste moves into, they're going to go up against this competitor right here, green polyurethane. It is also an isocyanate-free polyurethane. It's already been formulated into foams, adhesives, and sealants. It's patented, FDA approved, EPA certified, and has some outstanding performance characteristics. So as we create formulations for CO2 glue, we're going to need to compare ourselves to green polyurethane, look for competitive advantages that we may have in stronger bonding to glass, metals, or lower production prices using other recycled materials. One of the distributors of green polyurethane is Go Green World Products. The owner of that company is interested in seeing a clear coat formulation of CO2 glue. He'd like to start trying to make paints with it for industrial and commercial applications.
So to kind of summarize all of that, we really do think that we have a great product with many market options. And so the very first one that we would follow up with is going straight to market, working with the Bob Smith Industries. So our adhesive is almost there, ready to go to market. Bob Smith Industries will do some of the extra testing that we need and help us get this onto the market right away. Next, we really need to make some new formulations of this CO2 glue. And as Eric was mentioning, another one that we want to make is the clear coat. There's the most applications for it. It's used in large volumes, and it would be used by the people such as those coating ships or large areas where they want to remove having to protect every single person that happens to be in the area. We would also want to make variants of our adhesives. That should be pretty easy, changing cure time, things like that. And then move from there into rigid and flexible insulating foams once we have some money coming in and we can do the research to move from more of a glue and a clear coat into a foam. And then next, we really need to be able to compare directly our CO2 glue to the green polyurethane since they're the biggest competitor out there. And so we need to identify where our strengths are compared to the green polyurethane and try and find the markets that will give us the big advantage there. And then finally, we have to be prepared to move as a fast follower. Because green polyurethane is already in many of the markets that we want to go into, we can follow in right behind them and hopefully offer our product at a lower price and meet the qualities that they already have or exceed their qualities, such as binding with metals. And then also, if there are any changes in isocyanate regulations, so banning isocyanates from polyurethanes, that's really going to put a large demand for products such as ours out there. And it should be easy to sell our product to people who want to buy it at that point. And then also, if carbon tax credits increase, it's going to make it easier for us to offer our product at a lower price to the customer. And so with that, we'll say thank you and take any questions.
How long does it take to reformulate the glue? So, it's an estimate of how long would it take to develop the clear coat?
A clear coat. So we haven't gotten to the time scale on that, I guess, with the inventors. They say it's definitely possible. The clear coat's really common, and it would be the easiest step going from the adhesive to the clear coat, but I think we do a 20% time.
Do you research the supply chain for the chemicals going into your glue, whether or not that's a risk-free chain?
It should be really easy to get a hold of all of them. They're all commercially available. And then it's the process of putting the thiol carbonate and the amine together that's highly different than anything else.
Because you said green polyurethane has a patent, I guess what's the difference between their patent and the one you guys filed for that? Because that's something you can exploit.
I do know for the mixture, so we add a thiol carbonate and an amine together, and they're just adding a carbonate and an amine. So it's really similar chemistry. We have the thiol, that's the main difference of that.
So clear coat is an application and possible market. Bob Smith, so working with a major supplier, is not exactly a market. Do they give you insight what they would do with it, or it's just kind of explore it with you, or?
Well, they already carry a full line of cyanoacrylic super glues as well as epoxy super glues. And so I believe at this point we have a non-disclosed agreement signed with them. So the wheels are rolling, and so we're getting ready, they're only getting ready to send over samples. And so at that point, they're going to test it out. They're going to try to fine-tune this chemistry, and so that we can have 5-minute working time, 10-minute working time, 15-minute working time epoxies, which is very common with all the suppliers, producers.
You said that one of the features of your product is that it's easily tunable. So tell me a little bit more, if you would, what are the benefits? Why is it good to be tunable? What does it mean and why do I care?
So one of adding silica gel will change the flow properties, and so it makes it more easily spreadable, less easily spreadable depending on what kind of surface. So a clear coat, we're gonna want to be able to spread it easily, so we can add the silica gel. They've already tested that, they mix well together. Also, there's other binders or modifiers, like you could add sawdust into it if someone wants to make this a sandable product. And so they're saying there are several things they can add to it to change the product to fit the marketplace. So that's why we had so many options to go through working the CO2 Glue.
And it's more tunable than competing than substitutes?
Probably equal to the green polyurethane for sure, yes.
Do you have a chance to look at the building materials market at all and the adhesives that they currently use for their products, like insulated ceiling tiles and that sort of thing?
Sure. So that was further down our list. I'm sorry, can you repeat your question, actually? I didn't the first part of it.
Building materials.
Yeah. So it's further down our list. It would be a harder formulation for us to come up with past the clear coat. Clear coat would be the easiest. Coming up with a rigid or a flexible foam would be a harder one for us to do. It is the real advantage of our product is that it's the isocyanate exposure to the worker. And so really these foams are being made in industrial settings where, again, engineering solutions are probably in place. So a better one for a product like ours would be a spray foam insulation where a worker is subject to exposure. However, the inventors don't think that a spray foam insulation is going to work because of the slow kinetics in this reaction. So it's probably not a target.
What do you envision the relationship is with like the Bob's company? They only have that one application of how they would be using it, or you envision that just be you'd be licensing out, I guess, your patent for to be using that one application, so you can then find those other strategic partnerships in those other areas for the glue to be formulated, or?
What we're hoping is that by having this licensing agreement with Bob Smith Industry, it'll generate some revenue, and then we can use that revenue to fund other formulations.
So it would be just for that one application, though, not, yes.
They don't have clear codes available, so we have to find someone else.
You said you have a monopoly in October. How did you get that time frame?
Well, we're expect the patent officer for Nettle. They're the ones they're closely talking with USPTO, and they're expecting. We were told by the patent officer that they're expecting it to be granted in the next 2 months.
So the materials that go into the CO2 are considered renewable, and that's my first question. The second one is, how could you predict the change in the cost of materials over time? For example, the isocyanate here is fossil fuel based. I don't know if it is, but versus this glue, it's not contingent on the price of fossil fuel. It's something that you could also pitch in the value.
Okay, so sulfur, one of the main components, is $50 a metric ton, cheap. The CO2 in it, right now they're buying it, but it could be pulled from the atmosphere as technology is better. Sequestration, like you said, the tax credits went up. They could even be paying them to be producing this. And I'm not the rest of the chemicals
Most of the basic chemicals you can just go online to the websites that sell them and you buy them. The prices don't normally change, but you could try to work into buying things in bulk and come up with contracts with those companies so that your prices are more set. But I wouldn't expect making this one product that the base products like the alcohols and things that you're buying are really going to shoot up in price.
So what are the 3 largest applications for this product? What would they be? I don't know anything about building glues. So what are the 1, 2, 3 products?
So 34% of polyurethane is used in the construction industry, and so a clear coat would by far be the biggest, quickest application, the biggest market. However, we've got a really good competitor in that space. So
let's just stop right there. So is the performance of your product equal to that competitor?
That's our assumption.
So it's not better, but it's equal.
The one thing where they think that will be better because we have the added thiol compared to the green polyurethane is that we will bind better to metals. And then we also have extra hydroxyl groups, so binding better to polar compounds such as BOS.
Okay, and so there could be a performance benefit.
Yes.
And then there's certainly a environmental benefit, is that what I heard?
So we should be about 10 to 20% CO2 in our product, and so that's where we're hoping to do the CO2 sequestration, and then the added sulfur. But I do believe green polyurethane, other than the sulfur benefit, they can get the CO2 benefit.
I just think, just the quick observation is that you have some, potential performance benefit in your largest potential application, and you have the environmental story as magic for the marketing side of it. That's pretty compelling. So, you know, it's the, so quantifying that, making that, you know, really understanding that environmental benefit is really key. It's a differentiator. You keep talking about this other product, you know, and you almost sound like you're revering this other product, but actually your product works better and it's more environmentally friendly.
We still have to do the direct testing, but that's what we believe.
Okay.